All right, I'm going to record a quick video on how to make the laser cut models for your massing out of the cardboard. So I'm taking a building off of our site over here. It has a weird like bay in the back, which I think we'll want to talk about how to do like multi-heights. Here's one that I tested out, but it isn't really going that smoothly. So we're moving down here. Um, so you guys will have extra information to pull height from. You're going to draw the elevations as well. Make sure you coordinate the height of your elevations and the height of your model. I have extruded this curve using EC. I'm in full model scale, so I have to type in 38 feet, which is like a very typical height for row homes. And since this one has a bay on it, I kind of get some information that there's probably like, it's probably just back here. I'm not going to check, but I have a strong feeling that this comes down and might even slope. Maybe I'll do something crazy. So we pull this. This is an art, not a science, but you guys will want to be a bit more careful when you're making yours. Bring this down a story, and I'm just making sure I get some clean geometry as I do that. And then I'm going to slope it just for fun, just to make my life a little extra difficult. So I'm just going to pull, that was not good. I'm just going to pull this edge down like that. I don't know if anything, there's probably some stuff on our site that does this. Yeah, we'll pull it down somewhere like that. Okay, and since I did two booleans, I got this seam here. If I do merge coplanar surfaces, it'll clean up all of those double surfaces. I have some bad geometry up here. I'm not even going to do non-manifold edges. I can kind of feel it, but I think we'll just go for it anyways. So first thing we have to do is scale it. You'll see I've been making this on my cardboard layer. I'm actually going to put this on the mass layer because this is what we're going to extrude, or sorry, uh, this is what we're going to shrink down. So I'll start by isolating this. It just helps your camera when you move through this, like model scale and real life scale, it gets kind of crazy with the camera movement. So I'm going to start by drawing a 12-inch line. This represents like full real world scale. That's where we're at. And then I'll draw a quarter-inch line right next to it. That represents where we're going. And if I measure it, you see that it's 0.25, quarter of an inch. My file's in inches. All right. So I'll start by selecting the surface, the poly surface. I'll scale command. We're going to start on the 1 foot line. We're going to start at the end of it. And then we're going to go all the way down to where it says 1 foot, snap to the end. And then I'm going to click and set that reference point. And now wherever I drag it to, it'll set the scale of 1 foot to that measurement. And so I'm going to hold tab to lock it here, and so that I can click a quarter-inch line. So now I've converted 1 foot to a quarter-inch using a graphic approach. So this is what we're going to build out of cardboard essentially. And I'm going to copy and paste it just in case I like destroy it. Some weird shadows right there. I don't like that. Anyways, we're going to start by taking the 3/16 cardboard layer, and we can just extrude it 3/16 of an inch. Since I'm in 3/16, or since I'm in an inches model, I don't have to type in inches, but you guys might have to if you're in feet. So bringing the floor up 3/16 of an inch. You can also use the calipers in the model in the DFL to verify the dimension of your cardboard, and it might even like have a label on it. Most cardboard's 3/16 of an inch. Okay, so I brought the roof and I brought the floor down. I'll bring this down as well. Since that's technically a roof, that's going to be really miserable. I already regret it. Okay, so now we'll start doing these walls, and as I start doing it, you'll see that like all these corners are colliding, and that we're kind of planning for that. That's where that competition of like removing material. That's bad. Come back to that. Removing material for the thickness of the cardboard is really important before you get to actually building stuff. All right, this one's also bad. Why? We'll just ignore that because this is a pretty straightforward model. I'm going to set the direction. If you get any bad extrusions like that, just set the direction, press D, So if I do the command, you'll see like there's shortcuts underneath each of these options. You can also click on it, direction, and I'm going to snap to it and just let like my ortho snap send it perpendicular to that face. All right, and so if I turn off the mask, I'll see that I got a pretty good shell coming together here. This one's bad too. Try these two again. So of course, two of the bad ones are not perpendicular to my grid. I could set a C-plane to this, but I'm going to just show you guys if you want to troubleshoot it. You could set perpendicular snap using OSnap. If I do like this, see if this one works. This is when like having the right OSnaps on can really save you some time. So I don't think any of you guys have bays. These corners, you would typically like miter them after you laser cut it. I don't know if anyone has that. That's more of like a physical craft thing because we don't have like a 5-axis laser cutter. You can't really get that. But we can account for the thickness of the materials. We'll just do this last face on the front. And of course, it's also not really a great one, so we'll make our own. We'll just make our own. And what I'll do, I'll make a line that's actually like wider. I just want to give this like a clean face. So we're going to move this like a tiny, like 1/32 of an inch backwards. Yeah. And then we can extrude, and I'll just like Boolean difference that and make a nice flat face. That is pretty small in model scale. I don't think anyone will notice, hopefully. If you guys have any weird lines before you get to laser cutting, I'd recommend doing that. Or maybe I'm just neurotic. Jury's out. Okay. So now we bring this in like that. So we have the shell, and delete this extrusion I made. And now we need to kind of clean up all the corners. And so since we know that the top and bottom are going to be the full size, we can actually just lock those in place right now. And then everything else we're going to do, I'll show you a really crazy way to do it. You use like the elevation view. And so like if I grab all this and come into the right view, zoom selected, if I do move face here, I can get the bottom face of everything and just pull that straight up like that. You can also Boolean difference it, but you leave some room for it to act weird, like Boolean difference does. So we'll do these ones at the top now. And so like same thing. I have this weird line. I don't know what that line's from, but we're gonna make sure we don't select it. And we just get that top layer of the walls, pull that down like that. We get this like this pollution of our scale line. We'll delete that. All right. And so now we did like most of like the top and bottom ones. I have to do these two are these are all gonna be weird panels. Don't do this to yourself, but it's pretty easy to fix. So we're actually gonna lock this one just so we don't have to worry about selecting it. And then we'll grab, you might even be able to grab all of them at the same time. It's just a bit more precise. If you press X in the aliases, it'll switch to ghosted, which is pretty nice for these kind of things. I don't like ghosted for everything, but it's good for that when you get to like see through. All right, and here, now we're kind of at that point where we decide what we want to run proud. I don't know. I mean, I've been kind of back and forth all day about it. I guess this is a cleaner one. We'll do it. We'll run it. No. I guess if you laser cut it really well, they're both pretty good. But it does let you, I take it back. I'm gonna make this video doing it this way. You guys should probably just pick a way to do it as a class. This is a good way to do it. They're both really good ways. You do see more cardboard this way, but it's a lot easier to glue together, in my opinion. Like when you're putting this front face on, it's pretty hard to mess up if you have some of the walls on already. But if the face is set in, You have to kind of get that perfectly flush on your own, and that can be kind of difficult. So I'm gonna say this way. Whatever you guys pick, just do it together as a team, and it doesn't really matter. So the same thing back here, where we pull this in 3/16 of an inch. And so this is where like some of those tolerances come into play. We had some pretty bad line work. Some like why didn't that extrude straight? Is the C-plane in this model crooked? If you guys are working in the site model, I would say get out because this thing is not okay. I feel like the C-plane's messed up in here. I mean it. Um, since I'm not actually going to laser cut this, I'm going to do it here. But this would probably not be something you want to laser cut out of cardboard because it would burn and catch on fire likely. So here I have like double edges. Not good, but I think it's okay. This is, you know, context model. We're going to laser cut it. So also you see like things aren't really, there's weird geometry here, but we're just pulling planes out of this so we can build it in the real world. We don't need to make it like perfect to a nanometer. Sometimes that's fun to do for like our own projects, but we're just making row homes for the site model. I think we'll survive. Here, because of my slope antics, I now have to account for the height change. So great, we'll just pull this edge up to that line. And so here I would actually want to pull this down as well. If you guys have slopes in your scope, it does look pretty cool, but it's kind of a pain in the butt. Only for the bravest souls. All right, so that looks pretty good. And so we'll just do a little pass. So we know the bottom's good. This has been pulled in on the front, it's been pulled in on the top, pulled in on the back, and pulled in on the roof. These corners we'd have to miter when we cut them out. You look in the plan, they overlap. That's all right. I don't know. I think my right click just broke. That's crazy. Well, wait. I can't orbit anymore. I don't understand. Okay, so so I just had to restart Rhino. It's still not really working. I don't know. I've lost the ability. Did I? What did I do? Oh, I like broke this view. That's crazy. What? Like, what even happened? I don't understand. I somehow destroyed that view, but we're back now. And I was checking all the offsets on the material. Looks like we're pretty good. The tops are down. Pulled these walls in. This is kind of annoying. I don't know why. I guess this line here isn't parallel. Yeah. So we're perpendicular. We'll just pull this in. I'm sure I won't regret that. Because I'm already regretting it. Whatever. Alright, so now we'll unlock the roofs. We're ready to move on to the next step of like prepping this for laser cut. So we'll just pull it over here. And this is like a weird thing I do just to make sure I don't have to deal with like poly surfaces and make 2Ds are kind of annoying. You get a lot of lines. I'm just gonna explode this. Press middle mouse button. It's the explode button right here. You can also just type in explode. And I'm just gonna grab the outside walls because essentially we want these to be planes, like really clean planes. I don't like that it's doing. Oh no, that's fine. We're cool. And so like at this point we can actually kind of lose the thickness of them. This is going to make it easier to export the curves you need to send to the laser cutter. You have like a make 2D of this, you might get double lines. And again, like cardboard is probably the most prone to catch on fire. So I would avoid double lines. Like even these two, how far apart is that? A quarter inch. Okay, that's probably fine for cardboard. It might be structurally compromised, but it won't burn, hopefully. All right, and so we take all these and we actually just lay these flat. And so like I'm gonna use R3 or rotate 3D just because I don't trust this model or these shapes to rotate cleanly. These two we know are flat. We can just pull them out. You could use gumball here, but again, if you're working in the model like I am, this place is not okay. And so this is where you can go extra crazy in the care department and like when you're nesting this on the laser cutter, you can orient all the panels the same way for the walls, like a crazy person. So we'll just essentially make sure that all the walls are facing up. And so we can even stack these edges. So that's a common edge right there. I like to sometimes make these like fold if I'm feeling extra cheeky or I'm making it out of like Bristol. Folding stuff is really fun. Of course, that edge is not okay. We'll leave that one on its own. That one comes off of not there, there. And so the roofs might want to, the roofs and the floors can kind of do the same thing like that. And then we have this guy. And so again, like we want to make sure that these are all rotated so that when we're in the plan view and exporting them, they're flat and they're parallel to the camera. If you have any distortion, like if they're rotated like a little bit crooked, it's gonna like the foreshortening of the camera will ruin the accuracy of your laser cut. So we'll rotate it, and then again, since I have trust issues, we'll do the R3 to bring it down. I don't know why I trust like horizontal rotation more than vertical rotation, but it's just the way it is. And we have this wall. Okay. This one, pretty easy. So the way that R3 works, I don't even know if I explained it. You get to pick your rotation axis instead of just like rotate. It's just kind of like on the C plane. R3, you can pick what your axis is exactly. And it's a bit more reliable than gumball. Sometimes, like depending on your C planes, your gumball C plane snap, it'll like do some weird stuff. Um, I will not elaborate. All right, that's the last one. And so like that was probably pretty tedious, you're thinking, but this is the best part because this is essentially our laser cut file. We go into the top view, and again, make 2D. Make sure you make 2D this. Do not cut this line work here. I used to work down there. I watched someone spend like 6 hours cutting out like this extent of laser cutting, and it was ridiculous. So don't do that. Uh, it will my make 2D sends to like this origin of the model. So I'm actually just gonna like if you haven't done this already, highly recommend like taking whatever you're working on, and if it's not already at 0, 0, just like moving it there. You can do that with the move command and just by typing the coordinates like 0, 0, and it'll make your model run a lot better, even if it's like still pretty like a large area. Like when you're a mile away from the model origin, it just does weird stuff. Again, I will not elaborate. So here we have our lines. I like to ungroup them and explode them. And then just make sure that there's no like double lines. So like when I select here, I get two curves. Bad. We're gonna take this one and we're gonna move this point here. I do not want there to be two curves there. One curve there. So anywhere that you have curves overlapping, it's nice because it expedites laser cutting, but like this, oh no, it's just barely crooked. Well, that's bad. Like that, you don't want that to happen. So I would probably pull this shape here out of it and just let them be cut separately. This one's okay. There are two curves. If I got three curves there, that'd be distressing. This one also has two curves, of course. Nothing is easy. That one, What's the margin of error on that? 0 inches. I think that might be okay. So yeah, and then when you're laser cutting, you can print run from Rhino. Fact check me. I think it's an 18 by 32 rectangle. Fact check that. Seems small, but what do I know? All right. Good luck, everyone.